All right, welcome to lesson 7. We have now gone to the final part of double angle identities, and that is we want to see how we can prove some of the identities. Okay, now proving some of the identities, we shall still apply some of these ones here. Is an application of these ones here where necessary. Shall be applying them where necessary. Shall be applying them where necessary. By the way, this will be applied where necessary. Okay, so we have tan theta plus cot theta is equal to sec theta. Actually, I think this is meant to be sec theta cosec theta. Okay, so now I want to prove these identities here and see if they can come out. Now, solution, shall I say solution? So with this, shall have tan theta plus cot theta being equal to a sec theta cosec theta. Now, as when the way this one is, we use this equal sign. This one is the left hand side, and this one is the right hand side. So what happens here is we must either start with this side, work out on this side until when you see that after simplifying this side, the end result you get is this, or you can start from the right hand side and you prove that it is true for this. Now, perhaps we shall say from, please you start from any part you want. From, say for example, left hand side. From left hand side, what you're going to do is simplifying the left hand side, then we see if it will correlate or be the same with the right hand side. So from left hand side, here we have, I'll start from left, that is now a tan theta plus a cot theta. Now, you realize that, let's see where we are going. We want to see that this one becomes this in the long run. Then let's see, if you look at this tan theta and cot theta, but here we don't have anything like tan or cos or cot. So what we do, let's write the ratios of these ones here, because what we have in the answer doesn't have anything to do with the tan or cot. So now let's write this in a different format. So tan is the same as sin theta over cos theta plus, now this one is the same as, okay, a reciprocal, that is the same as cos theta over sin theta, because we said that cot is a reciprocal of tan. Okay, we're having this. Now, having reached here, you realize that the final answer you want to get doesn't have a plus, but these guys are having a plus. So how shall we do with that plus? I think if they are fractions and with the plus sign in the middle, we can solve those fractions, and our LCM will be cos theta sin theta. So when you have this LCM, cos theta sin theta divided by this, you will get sin theta. Now you find that sin theta times this will be now a sin theta times sin theta plus, now cos theta sin theta divided by sin theta, you will get cos theta. Now that cos theta multiplies this, it will be now cos theta times, again, a cos of theta. The next, what are we going to have? You multiply, that will be that sine squared theta, cos sine times sine. Sine times sine gives us sine squared theta plus, okay, this is over, our LCM is cos theta dot a sine theta. Now, a cos times cos will give us a cos squared theta, like that. But what do you know about this? Sine squared plus cos squared. Sine squared plus cos squared gives us a 1. So we shall now say, but sine squared theta plus cos squared theta gives us a 1. So you come and put a 1 in the place of those two. So that will be now a 1 over a cos theta dot sine theta. Conclusively, we shall say this can also be in the format of, okay, this can be the same as 1 over cos theta times, I'm saying 1 over this times 1 over, again, sine theta, like that. But again, how do we call this? How do we call that? So realize that, how do you call 1 over cos? 1 over cos is sec theta from reciprocals of trigonometry. Then how do you call 1 over sine? 1 over sine is cosec theta from the reciprocals of trigonometry. So our final answer will just be sec theta cosec theta. Then you can say quite easily done. It has finally come out. So you can as well start from left, rather right to left. Still it can come out. Okay. Let's now see the second proof. They are saying cosec theta plus tan theta sec theta equals to sec squared cosec theta. Okay. Now what we're going to do here, you realize that where we are going, we don't have anything like tan. We don't have anything like tan. And 2, here we don't have a plus, but we have a plus here. So what will you do? Let's have this in fraction form. So we shall say solution from, you start from the easiest side possible, please. Don't do to prove a point to an examiner that you know a lot. You start from this side, it's a bit simpler. So now I shall say cosec theta plus tan theta sec theta. Okay, now let's understand the meaning of this. That is 1 over the sine theta plus, this is sine theta over cos theta dot 1 over a sec is same as 1 over cos theta. I'm starting from left hand side, by the way. Sorry, I'm starting from this side to see that the other one will be true. Okay, having done that, then next we shall have 1 over a sine theta plus, here we shall have a sine of theta over cos times cos will give us a cos squared theta. Of course, this is a fraction, you can solve it. Here, let's get the LCM. Our LCM here will be sine theta cos squared theta. Sine theta cos squared theta. Let's divide. Sine theta divided by sine theta, you get cos squared theta. So you shall get cos squared theta plus sine theta cos squared theta divided by cos squared theta, you get sine theta. So therefore it will be sine theta times the sine theta which you have got after dividing. Again, sine theta, like that. So we can now say this will now be a cos squared theta plus sine times sine will give us sine squared theta over sine of theta dot a cos squared theta. That's what you're having. All right. So, but cos squared plus sine squared gives us a 1. So I will say now 1 over, from the identities, 1 over a sine of theta dot a cos squared theta. But this can be 1 over sine theta times 1 over a cos squared theta. Because here, you can, 1 times, you see that up 1 times 1 is same as a 1. So I've not changed anything in math. We call it creativity and it is acceptable. 1 times 1 gives us a 1. So I've not changed anything. So now, you look at this. Look at that. So 1 over cos, 1 over sine is same as cosec theta dot, now 1 over cos squared is the same as sec squared theta. And when you look at a proof, we have sec squared cosec, which is there. But then what you do, just come and put it in the right order, which is sec squared theta dot cosec theta. Then you can say quite easily done. That is about the proof. We are going to have like more 2 or 4 examples such that we can get to know how we go about the different proofs. Okay, let us proceed. So you have my example as part C. 1 plus sine theta over 1 minus sine theta equals to sec theta plus tan theta, but everything is squared. Okay, let's now say solution. I can say, let me start from left hand side. So from left hand side, please, you can just start from this side and come this side, but I told you the easiest way is that area which is simple for you is what you go with. So from left hand side, you have it that a 1 plus sine theta over a 1 minus sine theta. Now whenever you find a number in this format, whereby it is a single fraction We have a plus, then a minus down. Then here, what you must think of is rationalization. You must rationalize. How? Shall we say times? Okay, this is in the brackets. This is in the brackets. We shall now say times a bracket there, a bracket there. Now, if, say, for example, if here was to be having a minus, then I would multiply here with it because it must be a 1, then sine theta. Then a 1, then sine theta. If I was to be having a minus here, then here I would put minus, minus. But since I have a plus, then I'll rationalize using this 1 plus sine theta, 1 plus sine theta. The sign here tells you what you rationalize with here. If it is a plus, then you use 1 plus sine, 1 plus sine. What you do up, you also do it down, the same, such that when you cancel the effect, it doesn't bring something new. Like that. Now when you apply, you see that this times this will give you 1 plus sine, but theta squared over, because these brackets are similar. Laws of indices can verify that. Now, you see that here, we are having now a 1 minus sine theta, a 1 plus sine theta. Now, what do you see here? This one is the difference of two squares. And if it's the difference of two squares, what are we going to do? Shall now say that 1 plus sine theta, but everything there is squared over. Now, difference of two squares, that will now be 1 squared minus sine squared theta. This difference of two squares, we say that a squared minus b squared is the same as a plus b, a minus b. An implication that whenever you find this, you have the right to report this. And that's what we have here. 1 minus 1 plus. And that is it. So, you're now going to have 1 plus sine theta, brackets squared, over, this will now be 1 minus sine squared theta. Like that. Now what you do, look at this. You're having sec theta plus tan theta. We don't have anything like a minus. So let's find a way of making this guy here disappear. How? We know that from cos squared theta plus sine squared theta is equal to 1. When do we get this? When you make cos squared theta the subject, cos squared theta the subject will give you a 1 minus sine squared theta. So therefore, that's what we're going to substitute in, and we see if our proof will come out. So we're going to have 1 plus sine theta, close brackets but squared, over. All right, now 1 minus this same as a cos squared theta. Like that. And now this is the same as having, since they all have squares, the same as having this with the square outside. Then you have 1 plus sine theta, because a square applies on this, I put it there outside. This also squared, so I put it outside at once. So this will be now a cos of theta, just like that. Now, what we're going to do is, we now come and separate. We split the numerator. It will be, this is as 1 over cos theta plus, this is in the brackets, sine theta over the common LCM, which is cos theta, but everything is squared. So this will mean that here, what are we going to have? What are we going to have finally? What are we going to have? Just allow me to summarize this answer from around here. 1 over cos theta is the same as, remember when we have a bracket, this bracket is squared. So 1 over cos is the same as a sec theta plus sine over cos, the same as a tan theta. And you see that it is as required or quite easily done. Let's come to part D, another proof. Sec squared theta minus 1 cos x squared minus 1 is equal to 1. We want to say that, can this give us that 1? Now it looks funny. If you start from this side coming this side, it may end up giving a bloody nose or somehow hard. It's better to start from this side. So now we shall say still from left hand side. We start from this side. So the sec squared theta minus 1 then cosec squared theta minus a 1. We want to see, will it become a 1 in the long run? So here, we shall now come and say that, okay, from 1 plus tan squared theta, from 1 plus tan squared theta, this is equal to sec squared. Why am I using that? It's because they all have power 2, power 2. So I think about Pythagoras theorem. Which Pythagoras theorem? The one of sec. It is here. Then also from this, you know that a 1 plus cot squared theta is equal to a cosec squared theta. So we want to now substitute where necessary. Where you're seeing cosec sec squared, put this. Where you're seeing the cosec squared, put this. Then we see what the results will give us. Okay, where sec squared is, I will say 1 plus tan squared theta minus 1. Because this is just the sec, but there's a minus 1 there naturally, bracket. This will be now 1 plus cot squared theta minus 1. Okay, good. Now, this is a bit interesting. You see that this one dies out with that one, and even this one dies out with that one. So, what are you going to remain with? You remain with tan squared theta times, cot squared theta. But which science is here? This is tan squared theta times cot is the same as 1 over tan squared theta. And you see that this cancels with that to give us a 1. So you can now say quite easily done. As simple as that. More to come. Okay, we are back again with the more examples. Part E. 1 minus cos theta over sin theta equals to 1 over a cosec theta plus a cot theta. But please don't forget to subscribe. I told you that is the token of appreciation you can give in to keep this work moving. Okay. Now we have part E, which is 1 minus cos over sine equals to that. So still I will say in my solution, I will say from, now where should I begin from? Should I begin from right, left? Okay, from left-hand side. All right, so starting from left-hand side, we have 1 minus a cos theta over sine theta. 1 minus a cos theta over cos theta over sine theta. Now, what you're going to do here is, now look, you realize that the denominator, let's see, the denominator has a what? The denominator has a plus. So it means that the conjugate that we're going to multiply with here, the conjugate we're going to multiply with here must also be a plus. But of what? Of this one. So it will be 1 plus. It's because this one has a plus. Plus cos theta, 1 plus cos theta. That's how the magic moves. Then from there, multiply. But up here, can you see difference of two squares? Difference of two squares. Therefore, I'll have a right to say 1 minus, 1 squared minus a cos squared theta. That's what I'm having. Then down here, if you multiply, you'll get it as a sine theta multiply plus cos theta sine theta. After multiplying, that's what we get. Then proceeding, we're going to now have, we're going to have now this is the same as 1 minus a cos squared theta over, please, this was the difference of two squares. Or if you want, if you can't see this, you multiply this, expand this manually, and see the answer will come out as that. So over, right, sine theta plus cos theta sine theta. That's what you're having. Now next. All right. So, but 1 minus cos, since up we don't have anything, we all know that 1 minus cos is the same as 1 minus cos squared is the same as a sine squared theta. Sine squared theta over here we could have sine theta plus a cos theta sine over theta. Let's now see What are we going to have there in the long run? Now, how are we going to get the answer? Now, here up, they have a 1, but here I have sine squared. What you're going to do, to remove this, you see that when you have a sine squared theta divided by a sine squared theta, you get a 1. So it means that dividing all through by sine squared theta. Let's divide all through by sine squared theta. So it means that for this one up will be, all right, sine squared theta over sine squared theta, but also do that over there. Now everywhere I divide by sine squared theta. Sine theta divided by sine squared theta plus a cos theta sine theta divided by a sine squared theta. That's what you're having. You see that up, you have only 1 over. Now sine divided by this. Now part of sine will cancel with this, then shall remain with 1 over sine. Shall remain with 1 over sine theta plus. Now part of this sine cancels with this. They remain with the cos over sine. Cos over sine, so cos theta over sine theta. Now let's conclude our answer finally. Our answer will be 1 over, how do you call 1 over sine? 1 over sine is the same as a cosec theta, the same as a cosec theta, plus, how do you call cos over sine? Cos over sine is the same as a cot of theta, which is as required or as simple as that. All right, good. Now let's proceed. Another example is part F. We have cos theta over that, sin theta over that must give us a 1. That when you simplify this mathematically, the final result you get is a 1. And it is very, very simple and interesting. So what we're going to do here is, we shall say solution. So we shall say from left-hand side still. I'll start from this side. So we have a cos of theta over a square root of a 1 plus. Now let's put the identity for this. 1 plus tan squared. The identity for that you shall now say, okay, you see that when you make this the subject, when this one goes this side, you see that here we shall have sec squared theta minus 1. Please, maybe I'll go in for side work here. I know that tan squared, from the identity, tan squared theta is equal to sec squared theta minus 1. If you make the tan squared the subject, and I've substituted for 1 plus, where tan is, I'll put this. Okay, plus, all right, you have sine theta up over a square root 1 plus. Now, what about cot? Is that cot squared theta is equal to, from here, when you make cot the subject, the one comes this side, it will be now a cosec squared theta. That's what you're having. So this one will be, over here, this one will be, okay, minus 1. So it will be now cosec squared theta minus 1. Please be careful with the roots. It must be covering all the values inside there. This will cancel with that. So therefore shall remain with the cos of theta over a square root of sec squared theta plus, shall now have sine theta over, right, this is, okay, this has cancelled with that, which is now a cosec squared theta. That's what you're having. Now we shall now say a cos theta over, okay, a cos theta over, now square root of sec squared is sec theta plus sine theta over, now square root of this is just cosec theta, like that. Now let's simplify. Let us simplify. You realize that side work, I will need to give you some side work here. Look, we have cos theta over sec theta. This is the same as cos theta divided by sec theta. That's what you're having. And now this will be simply a cos theta divided by 1 over cos theta. And this will be simply cos theta times, because when you're working out this times, this will be reciprocal, cos theta over 1. And you see that the final result will be a cos squared theta. That's from the side work. So in the place of this one, we shall just put a cos squared theta plus. When you simplify sine, When you simplify sine, this will be now sine theta divided by a cosec, but a cosec is 1 over sine theta. This will give you what? A sine theta times, get reciprocal, sine theta over 1. And the sine times sine will give you a sine squared theta. So plus sine squared theta. And from the identities, how do you go this guy? A cos squared plus a sine squared. The final result you get is a 1. You can now say quite easily done. Just very, very simple to get. All right.